And now our invited presenter, Professor Christian Diedrich.
Thank you, Terry. Yes, my name is Christian Diedrich. I'm coming from Germany, in Magdeburg. Magdeburg is between Berlin and Hanover. And there's a university and a research institute which is called Institute for Automation and Communication, and I'm working there since 92, the last century, and I'm dealing with automation in general. Additionally, I'm responsible in the ISC standardization for EDD, FDT and FDI, and I think this is the reason I'm asked to give some statement at the current state here at ISA 104. And I'm happy to do this. Thank you, Terry, for the invitation. This is our building in Magdeburg, and if you are interested at the end of the slides, we have some where we are coming from, what we are doing. Okay, I want to start with two introductional points or ideas. One is, what is the starting point we want to have with FDI and EDD and FDT? And the main idea is from the system point of view, that we want to have device access everywhere in our system at any time, which means that functions like parameterization, diagnosis, or during commissioning or during service, we want to have detailed information what's going on in the device, and not only to have a look at the main process values, but additionally at parameters which adjust the device to fulfill the functions in the right way at the right place. And this slide shows us that there are the devices at the lowest level underneath of I/O subsystems or I/O controllers, but in our system at DCS level or at commissioning level or at even higher level, which means third-party tools, MES tools, we want to have access to the field devices. And FDI is announced to provide this, and this is the main goal. Okay, this is our intention. I want to give some background, which technology is behind this. The technology says that for each individual device, we want to have an individual access to the functions and to the parameters. This would mean that there is an application in a commissioning tool, in a service tool, and diagnosis tool, and this application have to be adapted to the individual functions and parameters of individual devices. And the idea is to have a representation of each device in this tool so that we have a general multifunctional tool which becomes the right functions by this representation of the field device, and this can be seen as a device proxy. This proxy is a representation, and we can integrate this proxy in these tools, and then or we can read and write and speak individual to each individual device. Now, if we want to have this general technology used in our automation world, we have to have a look a little bit in the device to abstract which kind of information, functions and parameters have to be in this device proxy. And in our digital devices today, we have already known functions in transmitters as well as in actuators, which is not shown in the slide, that we have the main functions and the parameters which are along this main signal flow, from signal detection using some electronics to the analog digital converters to scaling, linearization, calibration, and other functions which are the main functions of the device. And these functions are controlled by the microcontroller with this in this field device. And for this control, we need adjustments and operational parameters like thresholds, engineering units, scaling information, default values, safe values, and so on. And so this is one part we have to represent in this field device proxy. These are the variables and functions which we also known as the business logic of the field device. Not in all, but in many field devices, we have some local terminals, and using these local terminals, we can do some adjustment and some parameterization directly at the field device. If we want to do this everywhere at any time in our system, we have to have a representation of this local terminal functions in our proxy. So this means we have to have visualization information in this proxy. And last but not least, the communication access to the field device has to also to be represented. So if you have a look at the slide at the right side, we see that visualization, variables and functions as well as communication has to be represented in this device proxies. Now we want to have a look to our three technologies, to the EDD, to FDT and FDI. First we speak about FDT, and the FDT is an interface specification where this main component, which is a representation of the proxy, of the device proxy, is called the DTM, a device type manager. This device type manager represents the functions and the variables, that means the business logic mainly. Additionally, there are some information about the interaction to the communication system, which is shown at the lower part, and for the visualization there are extra programming, and this extra programming fulfill the interaction at the screen at the PC. This means the FDT solution as an interface specification has an implementation in terms of a fully programmed component, which is called DTM, which is dedicated to a Windows-based system, and specific programmed screen graphical user interfaces together with the device type manager. For EDD, we have a description language. This means there's a textual representation, and at least a tool has to interpret these declarations of parameters and functions. And more in general speaking, we have the three parts. We have menus and different graphic symbols where the device manufacturer can represent the graphical user interface. Then we have the variables, attributes, rules, and different actions and methods to describe the business logic, and we have a specific keyword which is called command to provide the information how to access to the variables and parameters in the field device. So the EDD has keywords which represent these three main aspects of our device proxy. Third, and the FDI technology with a device package integrate in this device package these different aspects, which means that the variables, the business logic, and the communication is represented in the business logic part, as well a little bit in the device definition part. There are additional user interfaces which are either represented by the EDD keywords, the menus, and different symbol keywords, and it is additionally possible to represent some graphics, the user interfaces, with additional programmed parts. This is from the structural point of view that the three different technologies represent these three aspects in this mentioned way. Now we have a look from the application point of view. The EDD, as already announced, have this interpreter, and this interpreter is together with the EDD, this device proxy, and this is running in the commissioning service and diagnosis tool. This diagnosis tool is a kind of data island, and only in a manufacturer-specific way the upper applications like inventory control or maintenance also can interact with this tool by a manufacturer-specific interface. The DTM is this device proxy, and this device proxy is running underneath a so-called frame application, and this frame application can be either in the same PC or the same computer as the DTM, or it can be in another place in the system. If they have a frame application according to FDT, then this can have access to the device type manager, the DTM. And thirdly, the FDI concept has now bring aspects of both technologies together. The already mentioned device package is representing the EDD in kernel plus the GUI, the graphical user interface, in the EDD specific, or in an additional way as the FDT top technology have done this. And additionally to this device package, there can be interfaces which are in the FDI specification modeled in UPC UA, which give applications, HMI application, PLS, DCS and MES applications potential access to this information in the device package, which represent these anywhere and any time in our system, as I have tried to introduce at the very beginning. Just to speak about the architecture and the implementation platform of FDT. A prerequisite to install a DTM and a frame application is that there is a system which is based on Windows, that need a Windows operating system. This can be a PC, and maybe if there's an embedded system which has Windows operating system, then of course it can work in embedded systems too. But today we only know PC-based applications for the FDT technology, and as far as I know it, handheld implementations are not known at this time. The FDI, as I've already shown, the device package has basically, in a mandatory way, the EDD. This is exactly the same EDD as we know from the EDD specification. And the device package is something like as the name says, a package. It's bring the different parts together in one handle piece. Additionally, if one has only in EDD, there are tools from the FDE, LSC, the corporation, which can convert this EDD into a device package. So there are real tool support to bring this in the device package. This means that the device package, this user plugin is optional. This device package are brought into the FDI server, and in this FDI server, it will be translated somehow in this information model, which is specified in FDI, and an FDI host can have access to detailed information of the device, where the user interface description is handled by the FDI host. This FDI host can be in the same PC or system as the FDI server with the device package are located, or it can be in another system in the all-over automation system interfaced by OPC UA. The initial implementation of these FDI hosts and the FDI server is also Windows, but there are ongoing investigations to use HTML5 to do implementation of the visualization. This would mean that an host implementation could be in future times using browser technology, which is today also usable in handhelds, and the already known handling of ADD in handheld terminals are available, but not in connection with the FDI technology today. So we think that it will take some months to have this investigation, and it's on the agenda to provide FDI server implementation and FDI host implementation using for mobile devices. What is not possible is that one can plug in DTMs as described before in an FDI server. Another solution is like this one. If one has an FDI device package, the FDT group or companies within the FDT group will provide so-called FDI DTMs. These are these device proxies, and these device proxies are only some skeletons, and the skeletons are interacting as an DTM, which is necessary for an FDT host, that means the FDT frame application. But internally in the FDI DTM, there are means that a device package like FDI has defined it and specified it, and which is standardized in the IEC, can be plugged in, so that if one has an FDI device package, one can plug it in an FDT host using this FDI DTM. This slide from Glenn Schultz. He is a CEO of FDT Group, and just to make clear, at this time the FDI device packages are only specified for hard Fieldbus Foundation, Profibus and Profinet. Just to bring the statements together, what is the situation for device manufacturer? A device manufacturer which provide a device package like FDI, which has this EDD, can work with both applications. With an FDI application, of course, device packages are defined for FDI, but also with this mentioned FDI DTM in an FDT application. One device manufacturer needs one device package for one individual communication type of the device. That means if one has a temperature meter, one for hard, one for field bus foundation, one for Profibus, then he needs 3 different device packages, because the details of the communication access are specific to the communication system. But providing this device package, there are many parts of the device package which are the same for different communication systems. This means that one device package is suitable for both FDI and FDT. The FDT Corporation provides the tool set which provides a conversion or transformation from EDTs to this device package. Additionally, if one has only a EDD, one can provide this device package without any changes. But if one wants to have a more graphical or additional and advanced graphical user interface, then one can add an additional UID in this device package. The FDI group companies provide these FDI DTMs to integrate the device package in FDT frame applications. A device manufacturer which provides a FDI device package can use or can provide this to both to FDI and FDT application if the FD provider has this FDI DTM. Now we have a look from the host system provider. The host system provider, which supports FDT frame application, can provide both. He can decide if you have a FDT or an FDI host, because the device manufacturer provides a device package, and these device packages are workable in both applications. But if a device system provider wants to use only FDT frame applications, then he has additionally to offer these FDI device type manager to integrate the device packages. So he has an extra work to do. And if there are system provider which only have today the EDD interpreter and has not supporting FDI at this point, he has to extend the application to the FDI host and the FDI server, as I have shown before. Just to sum it up, in this time the device manufacturer has not to provide both DTMs and EDDs, because if they provide a device package, it is suitable for both host types of applications, the FDT and the FDI-like. So from the manufacturer point of view, it is a big step forward. Additionally, the EDD harmonization has reached a very good status today, because during this FDI specification in parallel, the EDD standard is updated to reduce the dependencies of the different communication systems, so that only a very few keywords and structures of the languages remains specific to hard field bus foundation and Profibus. So thank you for your attention.
Well, thank you so much for presenting this, Christian. I'm hoping this will be helpful to many people that are interested in FDI and how they're going to migrate their systems to FDI in the future. So we really appreciate you taking the time to put together the presentation today. Thank you so much.